Hello. So in this example, we want to determine what, if any, vertical asymptotes there are in this expression. So again, as a sort of standard first step, something I always do, and I encourage you to do the same when you have problems like this, is I'm going to give this thing a name so I can write that when I'm doing work. So I'm just going to call this thing f of x. Okay. And so if I want to find vertical asymptotes, then what that boils down to is I want to figure out where this thing has left and right limits that are going to infinity. So as a sort of first step, vertical asymptotes can only occur where there are domain restrictions. So the very first thing I'm going to do is look for the domain restrictions of this function. So just right off the bat, I look at this and I say, okay, I have a polynomial on the top, a polynomial on the bottom, so there's no inherent domain restrictions in terms of the types of functions, but it's also a rational function, meaning I have a top and a bottom, so I need to figure out where the bottom is 0, because that's, I can't divide by 0, so that would be domain restriction. So as a sort of first step, what I'm going to do is factor this thing. Now, strictly speaking, all I need is the bottom factored to do the step I'm talking about, but inevitably I'm going to need the top to be factored as well for a follow-up step. So I'm just going to do both while I'm here. Okay, so I'm going to go ahead and factor this thing. The top I can do factor by grouping. So I'm going to write this as negative x squared, which will get me 2x plus 1, I guess, with how I just wrote that, plus, and I'm not going to factor anything else, so I'm just going to write a 1 there to make it clear what's happening. And then the bottom, this would be some sort of like AC method, for example, but I need two things. I need to factor that apart as a quadratic, and doing that I would get 3x, let's see, plus 1 and x minus 1, right? So I can double check this to make sure. So that would be 3x squared, which is indeed what I have. And I get minus 3x plus x, that'd be minus 2x, which is what I get, and minus 1 and minus 1. So that's good. So I still have to finish the top. So then I'm going to get 2x plus 1 and 1 minus x squared over 3x plus 1 and x minus 1, and that's going to give me 2x plus 1. So I'm going to do something a little weird. I'm going to pull out a negative here, and I'm going to pull it out of this piece, so that's going to make x squared positive and the 1 negative, but that'll give me a difference of squares that will look right when I do it apart. So I'm going to get x minus 1 and x plus 1. So to be clear, I'll write it sort of as an in-between step here. This is 2x plus 1 negative, and then I'm getting x squared minus 1 in the top, because if I distribute that negative, I would get positive 1 minus x squared, which is what I started with. And I'm doing this so that I can generate that x minus 1 I'm going to want later, which may not be obvious, but I'm sort of thinking ahead here. Okay, so I fully factored this thing in a relatively nice way. So my sort of first step then, my first thought, or I should say my next thought, is to figure out where this thing has the domain restrictions, which is going to occur when the bottom is 0, which occurs when any factor is 0. So in particular, x cannot equal 1 or negative 1/3. So these are domain restrictions, not necessarily vertical asymptotes, right? To know that they're vertical asymptotes, what I need is that when I try to take a limit at one of these values, I'm going to get that non-zero over 0 form, right? So if I try to take the limit of this thing, so let's say the limit as x goes to, let's say, 1 of f of x, right, my big original function, which is now this thing. Well, if I try to plug in 1, what do I get? I'm going to get negative 2 times 1 plus 1 times 1 minus 1 times 1 plus 1 all over 3 times 1 plus 1 and 1 minus 1. Okay. So I did sort of a bad here. I shouldn't have an equal sign there. So I'm going to put like a colon here and say this is sort of scratch work, because I don't want to say equals, because I'm going to end up with something that is not the right limit, because I'm still figuring out what's going on with this thing. So this thing is equal to, not the limit, but this thing is equal to negative 3, that's 0, that's 2, over 4, and 0. But that is 0 over 0, which is, as you know, not non-zero over 0, right? But this shouldn't be too surprising, because this is actually occurring from the fact that we have an x minus 1 in the top and bottom, right? So really what I want to do is simplify this. Remember, I need to not simplify it to get all the domain restrictions, right? 1 is still a domain restriction, even though I'm going to simplify it out of the bottom. So before I simplify it, I should record my domain restrictions. But then I can simplify it and use that to do my limits. So if I do that, then my limit as x goes to 1 of f of x actually now is equal to, as it turns out, because now 1 is not a restriction. So I'm going to get negative 2 times 1 plus 1. And that got removed, so now I have 1 plus 1 over 3 times 1 plus 1, which is now 3 times 2 over 4, which is 3 halves. You'll notice this is not non-zero over 0, right? So that tells me that 1 is not where a vertical asymptote is. But if I look at the limit as x goes to negative 1/3 of f of x, and again I'm going to use a colon here because I know already that I'm going to have a 0 in the bottom, so I can't say that this is going to be equal to what I plug in. I'm just going to plug it in and see what I get as a result, as a sort of check to see if it matches my criteria. So I get negative 2 times negative 1/3 plus 1. That got canceled, so then I get negative 1/3 plus 1 all over 3 times negative 1/3 plus 1. And that equals, let's see, 2 times negative 1/3, that's negative 2/3 plus 3/3 is 1/3. Negative 1/3 plus 1 is 2/3 over 3 times negative 1/3, so that's negative 1 plus 1 is 0. And this is negative 2/9 over 0, which again is non-zero over 0. That's what I care about. And so this tells me that, so f of x has a vertical asymptote at, I remember vertical asymptotes are vertical lines, they're x equals equations. So x equals this x value, negative 1/3. So to recap, right, we want to know where the vertical asymptotes were. That occurs where I have domain restrictions, where when I try to take the limit, I get this non-zero over 0 craziness. And so to figure that out, I fully factored everything and recorded all the domain changes, all the domain restrictions, excuse me. Then cancel out, right? So record the domain change, the domain restrictions, then cancel, then test, right? So I was like, okay, I have 1 and negative 1/3. So if I test 1 in my simplified version, I get some nice number that tells me that this thing is a whole, not a vertical asymptote. And so not a vertical asymptote. I don't need to worry about x going to 1. Then I test x going to negative 1/3, plug it in, crank along, right, get to my number, I get this non-zero over 0. That tells me that indeed I do have a vertical asymptote at that x value. X equals -1/3. Okay. So that is that.